first year PhD student in AIS. Today I'm going to discuss a review paper titled Natural Language Processing in Accounting, Auditing, and Finance, a synthesis of the literature with a roadmap for future research. Actually, it's hard to present a review paper because it covers too many concepts and methods in this review paper. Moreover, I do not have enough time to present, and I am not able to explain all of them. Honestly, I'm still not quite clear about some methods mentioned in this paper. Hence, in my following presentation, I just picked some cited papers that I'm interested in to show their methods, the results, and my little thoughts about them.
Hey, Shane, maybe if you found some difficult to understand methods, those might be good ones to bring up in class today to see if your friends in class can help you understand them. So if you don't mind, at some point, tossing one of those out to us would be good.
Okay. So I think the major contributions of this paper is that authors synthesized the extant literature in natural language processing (NLP) in accounting, auditing, and finance areas to tell readers to establish the state of current knowledge about this area, to tell reader what have been done in NLP research, and more important, to inform and guide future research efforts for researchers like us, and to tell us what would be done in the future. And NLP has lots of definition, but authors cited the definition of NLP from Lee's 2001 paper. It said that NLP is a theoretically motivated range of computational techniques for analyzing and representing naturally occurring text at one or more levels of linguistic analysis for the purpose of achieving human-like language processing for a range of tests or applications. And I also find some other definitions from Wikipedia. And as we know, accounting practice is full of written documents such as 10K reports and conference calls intended to communicate message with information readers. And moreover, the growth in digital and social media usage by business has further increased the volume of unstructured text documents, such as tweets on Twitter's seminar paper that we discussed in two weeks ago. Also, the NLP research and application has considerable potential in the future to enhance communications. And there are many dimensions that NLP research covered before, but authors want to focus on the literature review about the combination of NLP and artificial intelligence (AI). It means NLP plus AI or some other machine learning techniques in the research. The next one about the methodology, how to write a literature review paper. So, authors first scan the bibliography of 4 literature reviews, these 4 articles, and then perform keyword searches in these 3 databases, ACM Digital Library, ProQuest, and the linked databases are accessible via EBSCO host. And author use these keywords to search in these 3 databases to find the related papers and test. These 2 tables.
Can I look at the keywords? Okay. I just want to see if we. So do these have to occur together? Like expert systems is not text analytics, right? But but it could be related to. Do they have to occur together, the keywords, or they looked at every paper that had expert system?
I think they didn't mention about how they put keyword, one single keyword or many keywords together to search the related articles.
Do any of you know? Are these all the keywords?
The keywords that the author wrote in the papers. I just
Think
subtract
they have
them.
like single, they search single like text analysis, they can have like huge results. So I don't think they did it singly. I think they add some more words to the research, the search. This one.
They didn't specifically say
But they
related
didn't
to
say-
it, but they obviously, when you look at the result of artificial intelligence research, you're not getting all text analysis. So they didn't include those in the literature. So
Right. They didn't include everything.
And these two tables summarize the searching outcome. The paper summarized 266 papers total, and most of them from original journal research articles. And about the method, 95 papers are using NLP plus machine learning or artificial intelligence method. But however, there are still many, 86 papers are using the manual text analysis, because these papers are most from the earlier time period of research. And this figure shows about the evolution of NLP research. The most interesting point is since 2010, the availability of efficient new text mining and NLP method with machine learning and artificial intelligence fueled an increase in research. And also we see that a decline trend involving manual text analysis. It's a transition from manual to computer to more technology method. In these two appendix, authors help readers to summarize and organize some researches in manual text analysis and basic text mining research papers. Because in the main articles of the paper, authors want to focus on the NLP application with machine learning and artificial intelligence. But they still want to help readers to pick some previous research, so they summarize these articles' information in the appendix. And next, about the sample size. It is clear to see that it is a dramatically increased sample size associated with the peak period from 2010 to 2011. Because the efficiency and enhanced processing capabilities that NLP with ML and AI can enable researchers to analyze larger data sets. And some scholars thought that NLP provides the ability to assess the content and context of text-based data for accounting, auditing, finance, and academia applications. And authors also mentioned that the 7 largest sample size were cited in these papers, ranging from 1.8 million to 98.8 million documents. And all these 7 papers are from financial area. And these 7 papers using the NLP with ML and AI methods such as support vector machines, naive Bayes algorithm, fuzzy neural networks, and decision trees. And 4 of them are focusing on the sentiment analysis from different documents from different resources.
What types of documents would have study with 100 million documents. What types of documents were those?
Some related, like 10K reports or some tweets on Twitters. So the original size of the individual document may varies from. For example, 10K reports is a longer one, but the tweets on Twitter may be much shorter.
But there's more of them.
Yeah.
So was that it? 100 million tweets?
Sorry.
Was it tweets?
Yeah, tweets.
The 19 million, was that tweets?
I'm not sure.
No, it's just like, so I think this is actually compared to the think case and also the automatic.
There's not 100 million.
Think 10K.
No, it's like documents is not including tweets. This is what I understood. Includes think case and disclosures.
Not so many things. It's important. So next one.
From social media? Did you say social?
It just says digital media sources.
So probably use our
And then continues to follow that on Twitter tweets. And
Yes.
posts made on live stream.
It's like one of the ones, not the largest one, one of the larger ones was the live journal study. Not only was the 98 million, but it was pretty high. Depending what they're calling this sample size, they're calling it by a document, they're calling it by like the number of sentences or the section of from something that's also affected that.
How far? Go ahead.
And NLP has enabled researchers to analyze unique data sets associated with digital media, such as social media, like Twitter, Facebook. And these 7 papers are get the original data from digital media such as Twitter and Life Journal, Dow Jones News Service, and Thomson Reuters electronic terminals.
One thing I'm curious is why they use Twitter that much, because I guess nobody uses Twitter that much. Not that much people. Do you use Twitter? No.
Because you're asking is
But general people, okay. Sorry.
Okay. So this papers also help readers to summarize and organize a lot of algorithmic approaches related with NLP and machine learning, such as this method. And also, there are some statistical classifiers also related with NLP and machine learning, and some of them are familiar with because they are used in papers that we discussed a few weeks ago.
Can you go back?
Okay.
So, tell me about that support vectors machine paper. That second paper, Humphreys et al.
This one.
Yeah. That's my first paper. Just wanted to point that out.
That's why it's notable.
It's Humphreys Moffat.
Oh.
I should have been first. No, it's Humphreys Moffat, Burns, Burgoon, Felix. But so in 2009 we got a grant from PwC to look at a natural language processing paper. And we looked at, this is a fraud study. So we looked at fraudulent companies and their 10Ks and a matched set of non-fraud companies. And so it's pretty early in the game for this type of study. It was published in Decision Support Systems, but it gets cited sometimes. Anyway. But just wanted to tell you this is my opinion.
But I didn't read this.
I know you didn't read all the papers. I know.
So in my personal understanding, I think that there are resources that we can choose to utilize these different algorithm method or classifier in our future research, but just have a brief understanding about their usage and characteristics, and choose the most appropriate one to utilize in our future research. And then authors summarize researches using NLP to help the classification of documents. The first one about the knowledge, organization, categorization, and retrieval. One scholar proposed an Edgar analyzer combined with NLP and intelligent agent help to retrieve subjective specific corporate data from Edgar system to reduce the manual operation. And this paper used the large-scale case study of corporate Y2K disclosures to extract this disclosure from Edgar using his proposed Edgar analyzer. And also some scholars proposed another method, Edgar extraction system, to extract financial statements disclosures from 10Ks. In this paper, authors use employee stock options information as sample to extract related disclosure from 10K reports. And about taxonomy and thesauri generation, scholars used a linearized phrase structure and support vector machines to analyze the semantic tone of debt disclosure from lots of financial news articles, and to generate a lexicon of financial phrase, and to assess the positive, negative, or neutral sentiment of financial information. About information retrieval, it means the activity of obtaining information resources relevant to an information need from a collection of information resources. And scholars use NLP with decision tree system to process over 2,000 journal articles in the accounting area and yield about 87% accurate classification. And about to classify financial statement content, scholars use self-organizing maps to determine whether CEO reports were consistent with the audited financial numbers. And some Taiwanese scholars applied TDIDF, but I think there's a typo in this paper. On page 164, it should be TF-IDF. Applied TF-IDF analysis and conditional random field CRF to track inconsistency between financial statement disclosure and actual earnings. And I'm confused when I first see the TF-IDF. Okay. Next part about authors talk about using NLP to predict something. The first one to predict fraud and about fraud detection. Scholars use linguistic inquiry and word count followed by singular value decomposition plot analysis to analyze lots of emails to try to find out the characteristics of deceptive emails. And they did find some characteristics in these deceptive emails. And Scholar used also SVM classified algorithm to analyze linguistic features of annual reports and to see the association between these linguistic features about and the fraudulent financial statements. And also other scholars used a similar method to analyze another resource of documents, the quarterly earnings conference cost. And about to predict stock price and other market activity, NLP has been deployed when researchers want to determine the predicted value of text-based content to predict about the stock price, trading volume, volatility, and exchange rates. And Chinese scholars want to predict Chinese stock price in numerous industries with their method with accuracy rate varying from 50 to 65%, depends on different industries. They propose a method called EMAQT, E-Media Aware Quantitative Trader, to analyze news articles and other online contents. And their method featured about post tagging, name entity recognition, and SVR, sentiment analysis. And in the sentiment analysis part, they create a Chinese edition of LM word list.
So just translate the.
I'm not sure about the details about how they treat this. We have to go back to read the journal article. But actually, last week I just realized that my master thesis advisor in National Taiwan University also created a Taiwanese edition of LM list in her governmental research project in 2011, the same year with the LM paper issue.
It's based on the LM list?
So, sorry?
It's based on the Lockton McDonald list?
Yeah. And they translate and compare to the Chinese dictionary and find some professionals in accounting practice area to make sure these words these words do have financial meanings in the financial report. Okay, about to predict firm specific characteristics, scholars employ NLP and vector-based classification model to conduct the sentiment and document similarity for IPO prospectuses. Also another different financial related documents. And want to predict the future firm performance of these IPO companies. And about the annual report and disclosure, as we know, manual text analysis established the financial statement disclosure can be predictive of financial firm performance. Also, using text mining techniques, scholars also reaffirm the association between disclosure and the quality of disclosures and the future performance. And scholars using the NLP techniques with machine learning and artificial intelligence to analyze the tone of NDMAs and earnings press release. They all find these disclosures from different financial documents are also can be a tool to predict the performance of firms. about the web content, scholars use NLP and some machine learning techniques with decision tree classifier to analyze the sentiment of 5 million Twitter tweets. And authors using these analysis outcome to predict stock price change in Apple, Google, Microsoft, and Amazon, these big companies' stock price and stock return. So with a high accurate prediction rate. And about the readability studies, these papers cited 47 studies about the readability research, and Professor Mulcreed
that was just a conference papers.
Yeah, they mentioned that researchers had a plethora of readability measures, such as these 8 methods. And this review paper, the authors in this review paper thought that the FOC index and FRA formula were used most often to assess narrative text in accounting, auditing, and finance literature.
You don't like readability studies.
Well, you know, when I first started as a PhD student, I was naive. So I did readability studies.
Yeah.
But we found today, right yet, 2017 JAE article, which is better than TAR and JAR, which is a readability papers.
Yes.
But it's nice because it's based on the plain English guidelines put out by the SEC. So the SEC says you should write, I wish I had done this. It's a readability measure that makes sense. So the SEC said you should write 10Ks a certain way so they're readable. You should use short sentences. You should use words that aren't too complex. You should make it readable, right? So finally they made a readability index that lines up exactly with what the SEC recommends. And that's the measure. They didn't just use some random measure that had been used in the past. They built one for that purpose. It's nice.
Sorry, what's the reference again?
It's called it's
Bog index.
JAE issue 63. I don't know the name of the title. These are something called the MOG index.
The title is a plain English measure of financial reporting readability. They use BOG index, B-O-G.
Bog or MOG? Bog?
BOG, B-O-G.
Bog. Swamp. Bog. It wouldn't be in this lit review. It's too recent.
A plain English measure.
And about the readability studies in accounting and auditing areas, this research highlighted significant association between the disclosure readability and current and future financial performance and earnings, quality, and persistence. Sounds familiar with because it's I think it's the lead paper that we discussed before, and the fraud potential. In finance research, there's a research proved that poor readability is associated with poor future performance. And also readability is associated with stock valuation, price volatility, and market response to analyst reports. And this figure shows the chronological and methodological distribution of readability studies. And it's clear to see that the darker the bar show, the more NLP and machine learning techniques involved in the research. And authors in this review paper asked 3 questions to readers. The first one, will future research provide new readability analysis? And will researchers develop new and innovative mixture of readability measures using text mining, NLP, and other machine learning and artificial intelligence method to create a new method. And the last one, really advent of new accounting documents such as sustainability reports stimulate additional studies. Coincidentally, my final project in this course is I want to use the sustainability reports and CSR reports as my raw documents to analyze. I'm glad that someone agrees with me. I hope that Professor Kevin also agrees with me. And about the future research opportunities. Authors mentioned that the master glossary, that is a glossary that provided by FASB. And this word list is updated periodically to include new terms, daily terms not used in the ASC, Accounting Standard Codifications. And you can find this master glossary under the FASB ASC website. But however, you have to register an account in this website, and you have access to get this master glossary. And about the future research in auditing, scholars encourage future researchers to refine and extend applications of NLP, SPM, and other models to risk assessments, bankruptcy prediction, and fraud detection. And also encourage to generate a fraud ontology. Also, can using NLP to help identify and assess companies' internal risks by examining these reports and financial related information about the companies, and help to create a new toolkit for auditors, and accountants, and corporate managers for their purpose. And about continuous auditing, author mentioned that neural networks are well suited to audit applications because they are particularly effective when a large database of private example exists with non-inputs and outputs. And I think that some projects related with NLP and continuous auditing are running under CAR Lab. And in finance, scholars encourage that to integrate analysis of traditional quantitative data and previous ignored qualitative data, such as textual base of financial related reports and information. Combine them together to get a new result. And that's one about the conclusion. Authors summarize research using NLP has led to certain insights, and these points are discussed and mentioned before the previous parts. And the increased availability and sophistication of digital documents and digital tools may become the opportunity for future research. I think it's an opportunity and also a challenge for us. And NLP application offer new means to obtain additional insights and create new methods of mining many textual communications in accounting, auditing, and finance. And for us, we have to work harder. There is a long, long way to go. So that's mine.
Good.
I briefly went through like some of the other presentations, so I like these are the framework model and also
this is the second time I'm presenting. So I'm at least one presentation ahead of you. That compensates for the fact that I'm a little behind in terms of coding. So at least I'm one presentation ahead. I usually did the first paper, summary for the first paper, but this week I did for the second, simply because they use similar data that basically maybe the same data that I use for my dissertation, conference calls, except that they did it for all firms, while I focus only on pharmaceutical industries. I don't know how they can get all the conference calls. I have to do it manually. So this paper is by Larker and Zakoyutina, 2012, in Journal of Accounting Research. I don't know the name of the journal. But the basic motivation in this research is to how to assess manipulation. Or here, manipulation here means the misstatement of financial report, right? And in the past, researchers have used accounting information, accounting-based model to uncover manipulations. And then there is professional organization, Audit Integrity, develop commercial models to they try to find the financial misstatement or financial misstatement. And authors claim that the results of these two methods are quite modest, although I don't find that they define what does it mean by modest in terms of percentage, for example, how much these last two models can identify the financial misstatement. So the objective of this paper is to create, let's say, new method to identify financial misstatement, and as you can guess, instead of identifying through numerical data, financial information, or from that model created by Audit Integrity, they try to identify misstatement based on linguistic features of company executives, in this case CEO or CFO presentation for earning conference calls. And others did some literature review on linguistic features. There are some papers analyze linguistic features in corporate disclosures. For example, Lochran and McDonald, right? I think the first paper that we discussed, and then use press release in accounting. Accounting papers use press release data. Davis, Spider, and Sealand, 2007. And the result of these studies is that frequency of particular words, typically positive versus negative tones, have some correlation with financial performance. But however, the most important criticism in this area is that word used in different contexts may have different meaning. Authors mention this criticism, but they still use the same method anyway. Authors did not really address this criticism or this problem, and I don't know how actually to address this criticism. Right? We know that words in different contexts have different meaning, but how to detect context in financial report using computer-aided program, I think it's very hard. So unless you do it manually, of course you can address this problem. But if you do it manually, then small sample, right?
talked about this once before.
Yeah.
So we talked about this problem once before in class. Do you remember what it was, Abby?
They create different senses, like they put the words with similar meanings together, and they.
Yeah, do you remember what that was called?
Senses.
I know, synsets, that's right. But it's in a large collection of synsets. It's yeah. So some people use WordNet. And they try to use that as a basis for classifying words by meaning.
That same paper also utilized like 2 or 3 word groups too. So they also looked at like context group, and they could use like a synnet, they could use like internet or like a WordNet approach, but they did group in the same paper also by 2 and 3 word groups to try to understand the use and meaning and context as well. So that to me is a more complicated issue, then you gotta create nets for those grouping. You would build that out as well for context.
But like you say, whenever you look at the individual word, you lose context.
Yeah.
And you can try to attach meaning to it, like the synset or another group of words. But they don't do, in this paper, they still use individual words.
Yeah, they're still using individual words. So they, I don't know, for the sake of fairness, probably they mentioned the criticism. It is fair, but they still don't do it. Right, and then so I go directly to the method, especially the method for them, the method that they use to create this word list. Right, so they focus on the deception. So the basic idea is that if we would like to predict the financial misstatement, then we need to be able to predict the deception by CEO, right? If this, executives, CEO or CFO. So if the CEO or CFO deceive information during the conference call, that means more likely the financial report is misstated, right? So the key is to find to create the word list to measure deception by company executives, right? And then how authors created this list? They go back to the psychology and linguistic theory. They basically refer to this paper, Fry, 2008, and then based on theory, there are 4 perspective used when psychologists discuss deception. First is emotion perspective, right? So according to emotion perspective, deceivers tend to use both negative comments and negative affect words excessively, right? And then from cognitive perspective, deceivers use fewer self-reference words and shorter statements. So the shorter the sentence, according to this perspective, the more likely the speakers lie, right? To lie or to deceive information. And then the third one is control perspective. Deceivers use general, non-specific language. So it's probably similar to the concept of readability. I mean, when we discuss readability, right, when the speaker use non-specific language, the fact that I'm not able to specify this thing means I receive this information by the way. I don't understand this part. Non-specific language. For example, this reminds me of the paper in the readability. So if the words have various meanings, more likely the speakers are deceptive. That's the idea, I guess. I forgot.
Well, non-specific language could be leaving out names of places. I mean, there's this measure of specificity that I was reading about. There's like
there's no
numbers, names of places, names of people. These are specific, identifiable, quantifiable words. So you could fit in. So an example would be we made a lot of money versus we made $10 million. Or we trade with someone in the East. We trade with China. You know. So those are kind of
referring to the specific.
They usually use the Stanford name entity recognition program. So it defines this specific language, and it's pretty common.
Thank you. And then the fourth one is lack of embracement perspective. Again, according to this perspective, deceivers use more general terms, fewer self-reference, so tend to refer to us, for example, instead of I, or refer to we, and then shorter answers. So basically, if you see the similarities among this perspective, first, deceivers tend to use shorter sentence, refer to self-reference, fewer self-reference, right? For example, I, so refer to more like third reference, and then more or excessive negative comments in their language. And then authors created this list. So actually there are a list of words here, but I put only in the categories instead of the words because the table is too big. So for example, the category is anxiety, and then anger, swear words, extreme negative emotions, and I think they take words mostly from LIWC, which I check LIWC have relatively fewer words in their list compared to, for example, Harvard General Inquirers, which has like thousands of words. LIWC relatively fewer in terms of number of words. And this is the word of certainty. So, for example, here the predicted sign is negative. So the more certainty words used by the speaker, the less deceptive, right? So you can replace this with uncertainty words, for example, hesitations. And again, this is probably, I think that's why they refer to the more general words. So if the speakers refer to specifically to the shareholders' value, the speakers are more less deceptive than if the speaker refer less specifically to the shareholders' value. And then again, with regards to the self-reference, the deceivers use self-reference. So they add other categories, first person singular pronouns, for example, I, has negative relationship with deception, but they, and impersonal pronouns, reference to general knowledge, have positive association with deception.
Go back.
Is it too small? So they use LIWC, which you can check in the website. LIWC.
Which one of these? So LIWC, the people who created that, they call it Luke.
Luke.
This guy from Texas, Austin, Jamie Pennebaker.
Oh,
kind of a big guy there.
So
Psychology.
that name in the website. Pennebaker.
Yeah. Pennebaker. Newton, LIWC. So one of those, I don't like LIWC or Luke for our research, but I used it once, but for my 911 call paper. But one of these is not LIWC, and I really, really like it.
Which one?
reference to general knowledge.
Okay.
So they made this category up. I feel like they struck gold, not knowing they did. Actually, it comes out in the results as being significant. But I can't remember the exact word. I came up with I like their list of words that reference general knowledge because it's pretty comprehensive.
Is this from Harvard Inquiry?
So they made it up in this paper. Yeah, it's really good. So just give me a second so I can pull up the list in a different setting. It was polygraph interviews. So these people were mostly like sex crime offenders. It's not accounting research. And they were being interviewed by a polygraph interviewer before the polygraph test, before the lie detection test. You have to create the content for the lie detection test by doing this extensive interview beforehand. And so I knew from the data like which people were telling the truth about their crime and which people were lying. So the liars did this all the time. They always were saying, everybody knows. So it was just really nice to see a similar result in a completely different context. Even though I don't think in this paper they're necessarily lying. It's really terrible, like people have criticized this paper. They say they're looking at these CEO and CFO interviews and conference calls, right?
Yeah.
And they say they're lying, the authors say they're lying because later the earnings were restated. Okay, they had to restate their earnings. So that's their evidence that they were lying in these interviews, that the earnings were later restated. And it could be that they were just, bad at what they did, right? And there's lots of reasons besides lying that they don't have to lie to have poor results in the future. So it seems like, to me, this means they're sharing bad news, perhaps. Or they may be trying to hide bad news, not necessarily lying.
Necessarily the financial step.
And but they're using this same mechanism, the same tool to kind of diffuse the responsibility for what they're sharing. Anyway, it's cool to me. I don't know if it is to you guys.
I find it very cool.
Okay.
The list.
Yeah.
That's why I choose this one.
On section 4, they say, our sandwich constructor uses a comprehensive set of conference call transcripts provided by fact-set system. I wonder, if they are trying to identify if managers, CFOs, CEOs, lied or not during conference calls. Okay, besides what you just said about lying, I agree with you. But didn't they lose many things using the transcript? Would not be much better to go through the audio? Because, for instance, if you ask me a difficult question, I'm the CFO, I don't want to answer your question, I would probably not only use, I would also see something like that I can use with my voice. But whether it's transcripted, I doubt it's there. It's not on the file, the word file. Is it there?
No, they actually clean the transcripts. They make it look like they're speaking in complete sentences. So they take out most of these pauses. Yeah.
Another. In audio, I think that we would also catch. If you ask me something that I don't like, I would probably get upset with you and be more aggressive and answer in that search. So the vivid of the audio is lost on the transcription.
Right.
Would it be feasible to do a similar reserve like this, especially for sentimental analysis, using the audio?
Yeah, absolutely. So we read a paper on that, right? Is it Burgoon, Mayu?
2015 new paper incorporating neural density already
I'm not innovative at all, so I'm so sorry.
No, you are. You're like Newton. You invented calculus in a different part of the world at the exact same time. But you figured, yeah, that's it's been done. So
There's audio inflection too. There's like changes in tone and stuff as well. Yeah, the speed and also the pitches of statements and things like that.
So what they did is they looked at the individual sentences. Like they had, I think, this paper was one. There was only one company, and they looked at the CEO and CFO separately, and they knew from the outcome when they were in each sentence they coded whether they were lying or telling the truth. So they did some vocabulary analysis. Do you remember the vocabulary measures? Tone?
Or like pitch.
Pitch?
Pitch change. They just do pitch.
Fundamental frequency.
Yeah.
Loudness.
The other books.
There's like popular software using PRAT that the display. So you look at that software and read papers that cited that software, and you have like all research studies that is local scholarly text.
Oh, okay. And then there's another one by Mayu and Venkatechula that did 40 phone calls. And they used vocabulary. They didn't use the sentence level. I think they just maybe combined them all. I'm not exactly sure. They just looked at one measure for a phone call.
And the findings, are they more accurate than these? Or we cannot say anything that
For that paper, I don't remember.
I don't think you could say if they were more accurate or not. It was kind of mixed evidence.
Was that
The audio paper.
the first paper I was talking about? Yeah, with that one, the audio was not as strong as some. That one did a combined audio linguistic cue. It added both streams of data to the results, mixed results. I don't think they did a classification. I should know. I was on that paper. I did all the linguistics.
With regards to pauses, I don't know the transcript that they use, whether it has eliminated pauses or not, but they use the word, they included this word, something like that, in the word list for hesitations. Yeah, right. It's fine. Although in the transcript that I collected for my dissertation, it is clean. So I don't know the transcript that they use. Transcript they use is
clean. It's clean. So
it looks like
so this paper that used 40 audio calls. I'm looking it up right now. So I talked to the authors, and they gave me the audio, and I sent it off for a better transcript, like a verbatim transcript that included all the pauses. Because I was wondering if, since their data set was divided into truth tellers and deceivers, right? So I was wondering whether the truthful CEOs used more pauses, or the deceiving CEOs used more pauses in their conference calls. And I found some somewhat significant findings. Do you want to guess which one used more pauses?
truthful.
That's right, the truthful CEOs. Why do you think so? Why do you think they did?
Pauses can mean that the speaker needs time to think about what information they feel. So when you think about it, so probably you being more careful. Is this right?
What do you think, Carter?
or reflective. While those are deceivers, if I know that I'm going to a meeting and I need to deceive you, I will probably give the first, I already know the answers that I might be provided. But if I'm okay, I'm relaxed to go to a meeting, I'm not keen to, I'm not focused on deceiving anyone. I would go, well, let's see, and then think it over. So would it be, there is a taxonomy used there. I cannot read anything from here, but the word you just said, excitation. Should pause be compounded with excitation or not?
Excitation?
I think so. Is it
Hesitation. Oh, hesitation. I agree with you. I agree with you. They're more reflective. I think that's the best word I heard. They're not worried about it. They can take all the time they want to tell the truth, right?
Yeah, because now I remember I'm probably off the track a little bit, but remember the German movie won an Oscar in 2009, I guess, about the spy during the West versus East Germany. So the technique used by the interrogator, somebody interrogate prisoners. So if the prisoners can repeat all the same thing without hesitation, that means a lie. But if you hesitate or it's not consistent, that means it's true. And so, based on the movie. So the same logic, if the CEO hesitate or being like.
What's the name of that movie?
Sorry?
Which movie was that?
I forgot the title. It's German movie winning foreign movie in Oscar. I mean, we got an Oscar for best foreign movie 2009. Or 2010. So now they get data for transcript from fact set research system. To be honest, I don't know this. I don't know their data source. I myself use Factiva, which is available from Rutgers Library Network. They get.
I thought people use Seeking Alpha to get these.
Yeah, but it's hard to. What do you call it? Yeah, they start from the beginning. It's harder to collect for Seeking Alpha. So I use Factiva. They use FactSet research system, and then for US companies, so basically they use all the transcript, right? For US companies from September 2003 to May 2007, I guess because all data provider for conference call start basically in the same date, including the Factiva also start from 2002 actually, 2002. So I guess that's because technology the technology, or probably they hired somebody to transcript the speech start in 2003. And then for financial misstatement, they get data from Glass, Lewis, and Co. Actually, this is not complete because then they add data of financial misstatement from AER, accounting, and auditing. I think that's official information, right? Enforcement, yes. The E is enforcement. So for financial misstatement from Glass, Lewis, and Co. And then AER, the enforcement body for this accounting. And then the last one is LexisNexis. So LexisNexis is basically only for news, I guess. Company news. And this is the parsing method that they do for conference calls. First, they collect all phrases that belong to corporate representative. So if you see the conference calls, so it usually starts with the operator introducing the executive, the CEO, CFO, sometimes even COO, the operating officer. And then after the presentation by executive, sometimes they have the Q&A session, right? So the second method used by authors is finding operator face that receive the first question. So operator usually said, okay, let's start first question and answer. So they try to find this cue, actually, right? How to identify the question and answer, and then they record the question of the same speaker. So how do they know that these are the sentences from the same speaker? Until they find the cue that the new speaker or the new audience said something. So that's the part. So they try to find the interrupts. If the operator said something or somebody else said something, that's the interrupt. So that's how they cut the part. And then, the data required that the question must come after the operator speaks, because in some cases there is no Q&A session in the conference calls. I also find the same thing in my website. My biggest question in their not in their method here, but how do they get the data all transcript so efficiently? I mean, the way I did it is manually. I tried this, but it doesn't work. Data is restricted. Even sometimes because I use Factify identify me, are you a machine? While I'm doing it manually, they still think I'm a machine. But they can collect all this data, 30,000 transcript. I don't think it's manually, they don't say anything on how they collect data or data collection process, but I don't think it's manually. Which is very interesting. So basically, these procedures allow authors to track questions, right? There are 4 categories of financial misstatement. NT is non-trivial. This is the less restrictive measure, just based on the information provided by Lewis, Glass, and co. But the most restrictive, this is irregularities. If the news identify, if the LexisNexis identify the company news as irregularities, so they categorize them as irregular. But the most restrictive is this information from accounting and auditing enforcement body. So if this body identify from A as misstated or try to restate the financial statement, so they put them as this in this category, so less restrictive. They did this cross tabulation, try to find how many firms identify as deceptive, and then at the same time restated the financial statement. I don't put in the presentation, but the range is between 6 to 16%, and the lowest score is from the most restrictive category, AAR. Right, and then they do some analysis, but I think this one is the easiest in terms of analysis. So let's say this part, the word counting, this is for CEO, no significant result, right? The argument is that the shorter the sentence, the more likely CEO being deceptive. Right? So we supposed to expect negative sign, but they don't find it in the CEO sample. They do find it in the CFO samples, and then they find sample for Dave, for example, and it is positive. So the more words they CEO use, the more likely that the company misstated the financial report. That's the example. And then this is the positive negative for CEO. They find result for positive emotion, excessive positive emotion, I guess. The more positive you try, the more positive words you say, right, the more likely you receive some information. And then the idea is that the more likely company misstate the financial statement. And then anxiety words, also positive. I forgot to put the CFO, but actually they find better result when they do CFO samples. So for CFO sample, word count is significant. I think it's negative. Okay. Anticipated. I forgot the CFO. Oh, CFO is positive. Oh yeah, the word count for CFO is positive. That means the longer
They are all parsing.
they are positive.
This is there is no
So they are like,
so I don't know.
oh yeah, you're right.
This is
They
plus minus
have
minus.
this, but all the results are positive, right? Yeah, including the word counts, because in the beginning they said the idea is that the longer the sentence, the more word counts. That means the more likely CEO or CFO being deceptive. But for CFO, it's positive. So the longer, the more likely they are misstated. Oh yeah, so they don't find a strong result actually. Now I realize it. Thank you. And among reference categories, first person singular pronouns and impersonal pronouns have significant negative association with the probability of deception, as well as negation words for CFO but not for CEO. And then swearing and extreme negative emotion words are predictive deception for CFO, which is not found in CEO. But there are some similarities. Reference to the general knowledge category, like the word you know, like everybody knows, is a very strong predictor that that an instance or the sentence is deceptive for both CEO and CFO. Right? Again, the how do they define deceptive here? Probably debatable, right? Because they define deceptive here based on whether the company later on restated their financial statement. Right? But they find that the more these words used, the more likely firms to restate their financial statement. And both executive use significantly fewer non-extreme positive emotion words and fewer third-person plural pronouns in distinctive narrative. And there is a modest negative association between shareholder value phrase and the deception of CEO. They did some additional analysis, but they don't provide the tables, I guess. I forgot once. The additional analysis. I think they did provide something there. But to be honest, I don't think that table. Oh yeah, this one is before. So they do the comparative analysis. They find a stronger result when they use non-trivial. And they do the out of sample analysis, and they still find consistent results. I think. Is there any? In general, I like the paper, although I mean now I realize it is debatable, right, between deception and financial misstatement. But it is interesting. Okay. Thank you.
Companies ahead of time, and I decided to redo it so that you can actually choose 5 random companies that have NDAs or 10Ks for all the years from all the options. Because initially I was looking for like 5 companies that I knew would be significant, like Apple, that would definitely have all the data. But I decided that was too easy, or just like silly. I don't know. Some of this approach is a little bit too manual. Early on, I just took all the quarters for the 5 years I was looking at and downloaded all those IDX files. So that's a lot of the same over and over. I probably should have made a loop, but I did it. I had one at one point that decided that the encoding in Unicode was wrong, so it needed it to be in Latin. Just one of them. Same file, just one wanted Latin, which is great.
So then took all those, concatenated them together, and filtered out into 10Ks. So this is just the head of it, but you get all the companies here. Reset that index so you have all of the files in order, so the index is in random numbers. And save that so we have a place to go from there. Then take that data and sort it by the CIK. And you'll notice immediately, and this is what I was noticing, is that in some cases, like K-Tron International, didn't have a 10K for other years. We want to have all 5 years. So in some cases, yeah, you have AAR Corp that has one for all of our added laboratories, but you want ones that have 5. In some cases, you don't. So what I did is I actually went in and grouped and counted the CIKs, and then I went through that and found places where the index, this index value was 5, and took those 10Ks out of the initial data frame. So the idea is that in cases where the CIK count for an individual unique CIK was 5, those are the ones I cared about. So it would be all 5 years.
But for the years 2011 to
2010 to 2014, I believe I went, but 5 years. So I want to make sure that I get 5. I don't want to have 4. I don't want to have 3. I want to have only cases where I have all 5. So I then created that grouping, and then because I have a problem, I decided that it would be a good idea to randomly select those. So I made a list of the unique CIKs from all those, which I don't know why I printed out all of it, but it did. Sorry for a resolution HTML output, but there's a lot of them.
Did it print them all like 5 times?
It printed all of them just individually. So because I'm also, some of this is me still refining this idea, I just created a for loop through all the CIKs, and I selected a random list of 5. And then I checked to see if the length of that list was 25. So in some cases, you'd select ones that weren't 5 because of other issues and errors. So I wanted to make sure that I actually had a list of 25 long, so 5 in each, because there were a few things that cracks. Admittedly, I made this approach about last night because I built the first version, and I decided I wanted to redo it with the randoms. So some of this is still to be refined. But what this does is that it breaks when it finds something that's a list of 25 long. So then it will actually create a grouping of an index file of 5 different companies, each with 5 10Ks, and then you can analyze this. So I've run it a few times now, so we'll actually create a different list every time it's a random group. You could set the seed for the random group to get the same ones if you wanted to get specific ones. The nice thing about this is that it lets us look at different groupings and different companies. So the initial approach I had looked at Apple and Microsoft and more kind of standardized companies, and that is great, but it's nice to look at things other than what we expect. So once you sort that, we then go through some of the stuff we've gone through in the past, which is downloading those files, checking to make sure we have corpuses, sorting those again to make sure we have them in order. Oh, that's there again. And then pulling out corpus and cleaning it like we've done before. So text processing we've used, so what we did last week to extract the MDNAs, exact same process, nothing changed from that. So we pulled those out, processed them, so none of this should be unfamiliar. And then here, so we cleaned the corpus, and then here's the extraction of the MDNA, which is over here. One of the things I've noticed that has come up a few times that even with the cleaning method, we've had some of the new line symbols still be there from the method we've been using. I think Mauricio's methodology still had some of the new line stuff. I think I tried to adjust it and couldn't get it in.
Yeah.
So
oh, you
I
take
just
it off.
extracted it separately because it keeps showing up for some reason. So that's just an additional find and replace, basically. So once we had that, we can then take those and use what we talked about last week, the TF-IDF approach. I pulled out the names of the companies and created basically an individual Panda file for each company. Sorted that by the date, so we had them in the right order. and then extracted the MDAs into lists, and then checked to make sure they were there. Transformed them and made them the DF vectors, so we could look at them, and then created the similarity matrices for each company. And then we got the matrices here for all the different companies. We can then extract those into the first, create a table, so we get the first line of each matrix. And then we're going to set, basically create the data frame using that. So we're going to set them across as the rows. We're going to rename the top as the years, and then we're going to rename the row names as the different companies in the order. And then we can save that as our results as a CSV. So there's another approach in this HTML file that uses the
Wait, stop at this table. So can you interpret that table for me?
Yeah, so this would be the similarity related to that first year.
Everything's, the first year is the base year?
First year is the base year, yeah. And so each one's the similarity relative to the first year. So in the case of the bigger companies, which I ran, like Apple's and Microsoft's of the world, they're pretty similar. But in some of the cases of these smaller companies or different companies, the changes were a little bit more noticeable. I think that has some to do with the larger companies being a little bit more set up in how they approach these reports, and less instability in what they're discussing. And also, in some cases, there's probably more direct references to previous years, as there's less change over time.
It's just such odd, that first company is so odd. All the rest of them they progressively get less similar.
Right.
Except the first company kind of bounces around.
Yeah.
It's weird.
Yeah. Like I said, the Apple and Microsoft one that I did, Apple was like 0.98 every year, same deal. But some of the companies, I think that there's references to previous years, or there's wherever their business is, a different cycle or different nature to it. There could be things like that. Or, who knows, tons of other factors that could affect how they write, how they change.
Now I know I can leave. A PhD student, I had to write a research proposal, and I wish I had had this class. I would have done something different. But I decided instead of looking at individual words, I wanted more context. Who mentioned that today? In your paper, right? So context matters. So I came across this measure called a lexical bundle. And a lexical bundle is a phrase, a common phrase, in a corpus of text. So it could be your 10Ks as a corpus, all the MD&As, a bunch of all the AIS journal articles, accounting journal articles. These are corpus. And what are the common phrases that are used? So those are what lexical bundles are. So I found this. I didn't know if it was popular or not, or well cited. I don't know. So I said, "Oh well, lexical bundles, okay." So I decided I'll look for lexical bundles in the MD&A, see what are the most common phrases. So eventually, I figured, if you look for a single word, how many different words are there? Like, there's 100,000 words, right? 150,000 different words. If you look for a phrase, if you look for two words together, then you just can basically square that number, right? And for the possible number of words or phrases, it's huge. Well, I was looking for 4-word phrases in the MD&A, and there's just millions of them. So I guess Pickle was out of the question to store all these millions of phrases. Maybe I could have used Pickle. I don't know. But I decided I wanted to store everything in a database.
The database is better.
Oh, thank you. See, if Mauricio says I did it right, I know I did it right.
Yeah, you did the right thing.
I did it right.
Database is always the best solution for store data.
For what data?
For any kind of data, the better solution using a database related database.
So I thought, all right, I'm no database expert. I know Microsoft Access, but I knew of MySQL, so I downloaded MySQL database environment, the relational database management system, and I thought I'm going to use this. I'm going to store all my lexical bundles, possible lexical bundles. All 4-word phrases, actually, I'm going to store in the MySQL database. It's been so useful to be able to write to a database and do some, use it in certain ways. So I create calculated columns. I keep track of all kinds of stuff. So I think it'd be useful for you guys to have experience with MySQL database. At least you should know how to write to a database, to maintain the data, and then you can also query the database using Python if you want. So what we're going to do now is talk about the database. So I'm trying to decide if we should install MySQL in class today, but it's probably a pretty big download. How big do you think it is?
No, MySQL is very small.
Oh, it's very small.
Very small, like 50 mega.
So let's talk about the data, right? Let's pretend we have 100,000 10Ks. Okay, we want to extract all the 4-word phrases. And then we want to store it in a database. So the question is, how do we do that? How do we design our database? How many tables do we need? And how should they be connected to each other? So I'm open to suggestions. I've done this, okay, so I could show you what I did, but maybe you have a better idea. So who needs a little refresh on relational databases? This is a 2-minute refresh. So you have tables. So here's a table, and they have a primary key. You know what that is?
Yeah.
It's just an identifier, the ID. So it could be, I don't know. So you have a primary key, then you have attributes for that table. So if you have a table about a company table, okay, I have a company table somewhere. So table company. What would the primary key be for that company? CIK could be. What other types of primary keys are out there? What? Company name? Well, I mean, that'd definitely be an attribute. What else? What?
Install the book?
Yeah.
Ticker? Oh, ticker symbol, yeah.
This for sure.
What else?
Industry.
So industry could be,
The community is different.
that could actually be a foreign key, right? So, but yeah, you can put that on there. So I can put SIC, right? Something like that, or NAICS. SIC code. There are other identifiers. There's GB key that is used by CompuStat. So GB key. There's QSIP. That's used by who created QSIP? Is that
You have to start.
I can't.
Start again.
No. I'm trying to figure out my intro.
Okay, because just
Here, double click here. Just
SRV.
So one of these should be our primary key.
it's just not.
Sometimes with one company, I think that their CIK could change over time. And maybe these can change too. So maybe we want to create our own primary key
Yeah, preference.
and keep track of these types of changes. Yeah.
Okay, I just follow on your. So CIK could change with time. So we
I think the companies have changed CIK in the past.
And like the random thing that I did, I noticed that the CIK would change, but the company name would stay stable, or the company name would change, but the CIK would stay stable,
Yeah.
which is why there was issues there
Yeah,
too.
it's like that.
So you
I
have
had the problem
It's
with the
running.
name, so I
But I don't know
choose
how to
the
connect.
CIK.
The CIK is pretty good.
Yeah, so
Yeah.
the name was changed.
So the name changed.
Yeah, change. So, for example, company, they just say they put
Is it
sometimes
possible?
COM. So sometimes they put company.
So let's pretend we have another table called table industry. And let's say that the primary key here is SIC, right? And there could be a description of the industry, and then maybe there's other things, right? So SIC is a primary key, and here, what's it called? The foreign key. So that's the essence of a relational database. Okay. You create tables about one thing, like the company. Put all the information, one line per company. Industry, one line per industry. And then if you want, and then you can relate them together with the primary key, foreign key relationship. So you just create some tables to model whatever it is, the data you're storing. But you look at each thing, each concept in your model, like company, industry, and try to create a good table to model that. So that's very brief. Very brief reminder or review of relational databases. Now, what we want to capture is millions of phrases that could exist. Because actually, I looked at 4-word, 5-word, 6-word, 7-word, 8-word, 9-word, and 10-word phrases in the MDNA. And there's millions of them. So I had to use a database. So how would I model that in a database? Now, what we don't want to do is put the names of the phrases across the top, right? Because you usually don't have millions of columns. Usually you construct it so you have millions of rows. Because what I want to be able to do is say, oh, this company has this phrase this many times in this year. I want to be able to answer questions like that. But I have to somehow store the data in the database. So I need a table to hold the phrases. I need to keep track of when the phrases appear, when each phrase appears in each year, in each document. This is not trivial, right? So do you guys want to think about it for 5 minutes and then give me your ideas on how would you structure the tables? Maybe you want to draw some tables. Say, oh, this one has phrases, this one has documents, and now I can write a query and combine it all this way if I needed to. That's what I did. So. So I'll give you a hint. Right? We need one table that holds the phrases, right?
Yeah.
So somewhere I'll have a column called phrase, maybe forward phrase, forward phrases, and I'll just list all the phrases that I find, just once. So that's one thing I could do.
How about you just add the columns of year and document? For example, if one phrase appears in a row, then if it appears in 2011, then you put 2011 in the second column and the name of this. Yeah, add a column called year and then add a column called document.
Like that? Okay, so what goes in the first row? Just give me an example.
I like text mining.
Okay, and then what?
Year 2017. Document.
10K from...
Okay, 10K.
But which 10K? Like Apple 10K?
Okay.
All right. And then how many times did this appear? Should we put a count there too?
I guess
for example, you're looking for like sentiment analysis or something, and you analyze each of these phrases for sentiment, you could do a dummy code like positive, negative, risk, adverse, and say yes it is, yes it isn't.
That's a good idea.
Because
This isn't going to really work like this, Abby. It's not. Because what if we have to do, I like text, like we want to do a new company, we have to write this exact same thing. Well, first we got to do Apple again, because they don't change very much. So we have to do, how long has Apple existed? 30 years? We have to do 30 rows of this. So what we want to do is we want to have a table for phrases, a table for companies, maybe a table for documents. Okay, we need to separate it all out, but we need to do it in such a way where we can count the number of phrases per document. So this won't quite work. We need to have a little more separation. Okay. All right. So you guys can work on it. Ben, I'm counting on you. Actually, Marcio is the database expert. I'll leave this up.
Reading the full field.
What's that?
Create 4 columns of 4 fields.
4 columns of what? 4 phrases?
Yeah.
Why
Each
do you-
of the one corresponding one word.
Oh, each individual word in the phrase? Oh, that's interesting.
And then look up. But you'd still want information about the phrase as a whole, right?
Yeah.
So if you're analyzing the phrases, knowing information about the words in them is interesting. But if you're doing anything to analyze the phrase themselves, like let's say you were using like classification methodology to classify those from a previous corpus, and now you have information about the impact of those phrases, then the individual words don't matter as much unless you're then trying to extract additional information. So you could go a layer deeper, but you want probably, then you want 2 different groups. You want one that gives you information about the phrase and one that tells you what words are in it, and then another data table that then talks about all the individual words. So you kind of want to put 2 separate reference points. Because you can vary a table that's phrase meaning and you can vary a table that's phrase content. And the phrase content will give you words that you can then further explore, depending on what your intent is.
I like the idea of having a table of phrases and then attributes to the phrases, right? Like positivity, negative, like you were saying, positive, negative. Keep track of everything you know about that phrase.
Kind of. Because then if you wanted to go to a word level, you could still utilize that. But I would almost say it's probably just the more labor intensive to have one that references a phrase and then the words in it. Why not just have a thing that's all the words? So you don't need to go an extra step. You don't need to find phrases, because then you'd also double count, I would imagine. So if you have phrases that overlap.
So I have to connect to my database and see what I did. I have to start. Make sure you start your database first.
When you install it, it prompts a password.
Yeah.
Did you get the password?
Yeah.
So I don't. So, you have to create this connection and put the password. The password when you install it prompts a password. You have to open the workbench. New connection.
Yeah, I screenshot that password.
In your previous question, we want to know each phrase appears how many times in each year, right?
That's in every document.
And every document. How about we just for each document we create a table?
Okay, good. So you want a table of documents?
Yeah.
Okay. What are you going to put in this?
Phrase and how many times it appears in each year. Can I draw there?
Oh, okay. If you can reach the top.
I can. I will draw in smaller version.
All the time it's gonna so now it's going to exist in all the user.
Put the new one. I don't know. Why they don't are blank. I'm trying to connect my.
But I'm not sure how many.
Because I understand my.
Did you download the workbench?
I download myself.
What's the question?
We want to. How do we store our data so that we can find out which phrases appear? We want to index our documents.
Okay.
Basically. Which phrases appear, which documents, how many times, and then we can aggregate it by company, aggregate it by lots of things. Actually, So we're just we're designing our database here.
Sure. It's the most
This
important.
one is.
So we
Okay.
first create for each company because we can identify each company by the CIK. So for each company, we just create this table. Here is the 4-word phrase, and each year we calculate how many times this phrase appears. So this one is the times this phrase appears in this 2017 10 case. And so for each company, we create this table, and then we create a summary table where this column is the phrase, and this one is the total number this phrase appears in the whole all the 10 cases. So this number is just the sum of for all the CIKs. If this is what you mean.
It may be. I just don't know. I just can't follow it quite. Thank you very much. All right. I'll just erase it. No, I won't erase this. This is what my school teacher used to do. Save. Because the janitor comes at night and cleans the chalkboards. So if you want to save it, you have to circle it and save it. Okay. I think what we need to do is create a table for phrases, a table for documents, a table for companies, and I think we'll be able to, maybe we'll need some relationship tables. Yeah, I think that's what we need. So let's do that. Okay. Okay. Do you want to take a picture of it? All right, what would go in a document table? Like document name, maybe a doc ID, some number. So document name, I don't know. Document type. What else? So the name would be, you have, so a document can only pertain to one company. So let's put the company like a CIK right here, right? Okay. So this doc ID could be just a unique identifier that we create. It could actually be something like when I create a doc ID in my files, I'll do like the year, the company, the CIK, and the doc type, like 10K, like 10K, something like that. This would be, we just need a unique name for the documents that's going to uniquely identify each one. Okay, so we have a phrase. The phrases are all going to be unique. I mean, the name of the phrase could be the unique identifier. It could be. We would never repeat the phrases here, so we'll call it phrase ID. So I like text mining is the first phrase ID, and this is the phrase itself. We could. Now, a document has many phrases, and a phrase could appear in many documents, right? So this is called a many-to-many relationship.
Is that the phrase ID or the phrase content?
Yeah, it's the same. I mean, I could give a phrase ID like some random number. I could start counting from 1.
Okay.
I could do that. I mean, maybe I should do that. And then you can have a phrase, like you said, the phrase itself, we call it phrase content. It's fine. I was just saying the phrase content will never repeat itself either. So it could be a primary key. So I like text mining. So with the tables, they're related to each other, right? And sometimes, a company could have many documents. It will, right? But a document will only ever pertain to one company. So that's like a one-to-many relationship. And in those cases, you think about it, we do what we did there. We can put the primary key of the company in the document table because a document will only have one company. So I can add it as a field here. So this is a foreign key. It'll relate each document to the company, right? So I put CIK as a foreign key there, or whatever primary key we want to assign to the company table. So, but table document and table phrase they have a different relationship. So one document will have many phrases, and one phrase will appear in many different documents. So to model that relationship, I can't just put a foreign key somewhere. Like I can't say, oh, I like text mining, and then put the doc ID next to it, because I need lots of doc IDs. You can only put one item in each cell. That's like the basic rule for first normal form. And we couldn't put the phrase ID here because there are many phrases in one document. So to model a many-to-many relationship, you have to use a new table. And it can be called a relationship table, a link table. I don't know what else you can say. So we create a new table. I'll put it right here. And the primary key for the new table is a combination of the two primary keys from table document and table phrase. So this is it works really nicely. So I put, here's my new table. Okay? Double lines. So I use phrase ID and doc ID. So together, these will always be unique. So you see how it works. Phrase 1 is in doc ID, call it D1, call this P1, okay? P1, D1, great. Phrase 1 is in doc ID 1. And phrase 1 is also in D2. Phrase 1 is in D3. Phrase 2 is in D1. Phrase 2 is in D3. Nice. So now I can relate every phrase to every document. I know all the phrases in every document. this is going to be a really, really long table, but it's better than repeating, like you said. This is better because we don't have to write this a bunch of times. Maybe it saves space, right? So just all the phrases and all the documents. Now, where would we put the document count? Like the count of phrases. Like, I still haven't modeled that or put that information in here yet. What's that? Yeah, I just put it in the relationship table. I could put the count. So how many times is phrase 1 in D1? I don't know, 25. That's a lot. Maybe just 2, 4, 1. Yeah, that could work. So if we create this database with phrases, documents, the relationship table we'll call whatever, table phrase, document phrases, doc phrases.
But that table would be an output of your analysis. You're not typing on at all.
You're not what?
You're not typing that on.
Right, you don't type any of that. Yeah.
That's not.
Right, yeah. Yeah, we're going to write code that generates, that does all the counts and just writes it all in the tables.
Also search for those phrases.
First you have to generate the phrases. First you create the phrases, then you what's that?
Can you create it like you can write the phrases?
No, not manually. We write code. So this is a really good point. So how do you populate the tables? So many databases are populated manually. Like Facebook data comes from us, stuff we type into Facebook. But this data is going to come from whatever documents we're looking at. So we're going to write some code. We're going to find all the sentences because we don't want to cross sentence boundaries. We may even not want to cross comma boundaries or semicolon boundaries. However you decide. And we're going to find all the forward phrases, and we're going to stick them here. Forward phrases. Or here. Give them all a unique ID. Then we're going to look for those. We're going to also have our documents that we found, right? And our companies. And we're going to look for these phrases in each document and create the relationship table. Phrase, document, count. So, what's the problem here? So if I have what if a word is longer than, what if a phrase is actually a 5-word phrase? So 5-word phrase could be for the year ending December. I found this all the time, right? It's actually, naturally it's a 5-word phrase, not maybe a 6-word, December 31st. Right? Maybe a different problem for a different day. We want to actually, what I did is I found all the forward phrases and I combined them into 5- and 6-word phrases if they naturally occurred together. I had a technique for doing that, but it's not that sophisticated. Otherwise, I wouldn't been able to do it right. So, have you guys installed the Workbench MySQL database?
I can't download.
No, we have to.
Oh, you can't download?
No, it's very difficult to install.
Okay.
There's several steps. You have.
So here's the assignment. Here's the assignment for this week.
Later you do that. It takes time.
So the assignment for this week, you don't have all the material for. So Mauricio is going to teach us how to. He said you can use Panda. Panda creates these nice data frames. You can use Panda to write to databases. Super easy.
Yeah.
Once we create them, you can even use Panda to create a database. And to create tables.
Yeah, you create tables.
Create relationships. And you just it has a MySQL.
No, if you wanna create the entire structure with foreign keys, everything, maybe the best way you create the design in the workbench, create everything. But the index, the primary key, it creates for you.
You can use Access database.
No, we're not using an Access database. Yeah, it is a relational database.
MySQL is that Access is pretty much the same thing.
But with Access, it's not quite as.
It's just a placeholder. Like
It's not quite as.
Access just
Can you write to Access using Python?
Yeah.
Create an ODBC connection to Access?
Yeah, you can. Actually, every database you can connect it through ODBC driver.
Yeah.
Yeah. But Access is not a good.
See?
Access is not a good.
And Mac cannot use Access.
Oh, and Macs
Yeah, Mac
can't use
cannot use
Access.
Access.
And half of the students have Macs. That's true. You would have to have a Windows operating system to install Access. That's true. You're right.
Yeah,
You're right.
there's
Access is fine
several.
most of the time.
For a small data set, Access works.
Yeah.
But yes.
You're not opening it. You just access. You're using SQL. You just add a table, create table, you can access data. You're not actually not using Access software.
Right. You're not using
So using the ODBC, you can.
Sure.
If you know how to use SQL.
Yeah. No, that's a good point. So if you hate this assignment, then you can use Access next time. So in your MySQL workbench, you can what you can do is you can visually build your databases, kind of like an ERD, like an entity relationship diagram. You can build boxes. Boxes, and you have the attributes, like the primary key and the attributes, and you can build relationships between, say this is CIK, it's a primary key, and then you have your table document, right? And CIK is a foreign key. Like you can build the relationships like this is the primary key. You can set all that up. I just want you to do really though. Four tables, okay? Do table company, table document, the table with forward phrases, and the table for the relationship table, okay? So you just need to build 4 tables visually in the MySQL workbench with the attributes. So take a picture of this. I'll take a picture and upload it also onto the okay. And maybe this one too. So this part isn't programming. This is just designing a database. So once you've designed it in MySQL, once you figure out how to do this, it's not that hard. I figured it out, knowing nothing. So you guys can do it. So I designed my 4 tables, and then what you do is you forward engineer your table. Okay, which is not, it's like the opposite of reverse engineering. So if I were to take a database and reverse engineer it, I could create this. But I'm going to take this and forward engineer it, and it's going to create my tables in the database. So look for forward engineering option in your workbench. And you might also need to have, before you do that, connect to your database. So the workbench will connect to your database. The database has to be running in the background. So in my computer, let me just show you how it looks. Yeah, backwards. So this is what the workbench looks like on my computer. So I can create a new model. I push this plus button. And I can add a diagram. you don't have to do it that way. Actually, you can add tables this way. You can press add table and put the column names in right here. Do data type, you can numbers, strings, whatever the right data type is. So you can add tables that way, or you can add diagrams. That's the way I was talking about. So if you're adding diagrams, you can just create a table, call it TBL.
Is that the same window as Thesauri?
What's that?
Is this the window before?
So the way I got here was I went to a new model. I created a new model. And I don't know if you have this. You should have something.
Can I access to file?
That's on the second. Yeah, there's a
File, new model. And then it gives me the option of creating this diagram, or I guess I can create my schema down here also. Either way is fine. So I add a diagram. You can add it. You can look at the different things you can add. So table, seems good, right? And then you can double click it, I guess, and name your table. And then give it a name. Give it attributes. Like doc ID, and that's my primary key. And I can give it another attribute like document name. And if you notice, maybe you want your ID to auto increment, something like that. So you can click on AI, which means auto increment. That means you don't have to actually add a value to that primary key field. If I add a new document and under doc name, it'll automatically add one to my primary key. So I can create another table like the phrase table. I can do all that, and then you can start figuring out how you relate them together.
What is the difference between the data type? Should we change the data type?
So
the first one is
varchar holds numbers and letters.
Oh, okay.
Yeah, you may have to look at that.
Yeah,
There's a lot of data types, but a blob would be like a bunch of text. A date time would be a date. But there are number data types as well. There's a lot of data types I have no idea what they are.
We should change it.
There's a lot of data. You may need to change the data type, maybe. But for a four-word phrase, I set my my maximum length to 100, which would capture any four-word phrase I imagine. You'd need like 4 25-word words. You're not going to get that. But I mean, I had it set to 45, and I think I found a four-word phrase that was longer or something. Maybe not, I don't know. But I set it to it. Anyway, once I created this, I forward engineered it. Like under database, forward engineered. And then I choose which database it goes into. So I use my local connection. I have a username. I have a password. There we go. All these different options. I just pick the default stuff. It creates the SQL. There. Now it's a table in my database. If I look in my database, let's see if it's there. So let's go here and connect to my database. So you go database, connect to database. Hit OK. And I have one called toilet. That must have been a joke. I don't have anything there. I don't know where my, I don't know if I named my schema, did I? Oh, MyDB, tables, table documents. Oh, there you go. Thank you. There's my table.